All right, good afternoon, everybody. Just gonna go through a little bit of our slides. If you hear some weird noises, it's my buddy over here. This is Windsor. He's all tired because we just went and played catch. So he's gonna lie down, probably not too far away from the ball. But just gonna go through a little bit with our presentation for today. So your job today is to complete through the slides and do our exit ticket for today. And today we're going to be going over like things like static electricity and what is it and what are the everyday examples and how electrons transferring between objects causes things like static. So the first thing, electrically charged objects come, all right, from the effects of electrical forces. So charged objects are going to have, whether they're positively or negatively charged, are going to have some electrical forces that interact with other things. And what does that look like? I think you guys know. So electrical forces are caused by cause the attraction of um, opposites. So opposite charges attract positives, attract negatives, and the repulsion of like charges. So positives repel positives. He's gone now. And negatives repel negatives. So opposites attract, like charges repel. Static electricity is when electrons move from one object to another, creating an imbalance of charge. So it's either going to have a positive charge buildup or a negative charge buildup. It's not a very big amount of charge. It's actually quite small, but it's enough to create some of those things we were talking about. So how does static electricity get produced? So when two things that are neutral come into contact with each other, if we rub those two things together, think of your socks on the carpet, so two neutral objects. As we rub those together, the electrons are going to be rubbed off of one object and onto the other. And those electrons are actually moving from one object to the other. And if we have more electrons on one object, then we're going to have a negative overall charge. And if we have less electrons on an object, we're going to have a positive overall charge. Again, leaves one slightly charged, or sorry, both of them slightly charged. The insulator usually is the one that's going to take in the electrons. They like to hold on to electrons, so they're not going to give them up. They're probably going to pull them in. So most of the time they're smooth, and then the objects that give away the electrons are going to be positively charged. So if they have less electrons, right, their number of protons hasn't changed, so their less electrons are going to make them positively charged. I don't know where to put my face. I don't know what to do with my face ever. When, when you rub your feet across a carpet, the electrons are going to be moving from that carpet. Okay, in this case, the carpet is the conductor, and your body is going to be taking them in as the insulator. So we're going to have a buildup of negative charges on your body, and we're going to see more of that tomorrow as you go through some of our experiments. So anybody who's ever touched a doorknob and you felt a shock, or a metal object, you felt a shock, this is what's happening to you. There's an overload of charges, whether that's on you or the another object, right? So one of you is negatively charged or positively charged. And the electrons want to stay balanced. They don't want to stay negative, or they don't want to, an object doesn't want to stay positive. It wants to stay neutral. It wants to work towards where there's equal numbers of electrons on and protons in each object. So when you come in close contact with a conductor, those extra electrons will move off of your body if you're negatively charged, or if for some reason the metal is negatively charged, they're going to jump onto your body. We see this a lot when we have our cells negatively charged. That's why we get the static shock. If if you poke your sibling when you're statically shocked, you rub your feet on the floor and you shock them, you're giving them those excess electrons and you're trying to become more balanced. We've said it a few times, conductors are the things that allow for electricity to move through them. All right, most of them are metals, things like that. Metals allow electrons to move really, really quickly. Copper is probably the best one. that we're going to talk about. Insulators don't like to let electrons move, so they can't carry those electrons. So if something's holding on tight to its electrons, we call those insulators. They don't like to let electrical charges move. That's why we insulate wires that carry electrical charges in rubber, which is a really good insulator. We don't want those charges traveling outside of the wire. The first one, we have direct contact. That's the transferring of electrons. So we didn't talk about electroscopes a ton, but electroscopes are little objects that have a metal ball and two metal foils inside. And when they become negatively charged through contact, so we touch something that's negative to the electroscope, those electrons go from whatever that negatively charged object was to the electroscope. And now, because negative charges like to repel each other, those two foil pieces are going to um, fall, or not fall apart, but push away. If you look on YouTube, you're going to find a lot of good examples of electroscopes. Friction is that rubbing, so it's still contact, but this is a little different. We're going to have that rubbing. So if you take a balloon and you rub it on your head, right, you're going to transfer the electrons from your hair to the balloon, because the balloon is negative, or is, excuse me, an insulator. It's made out of rubber, and that's going to give your hair a net positive charge because we've taken electrons away from that one. And then the balloon is going to have a net negative charge, so it's going to have more electrons because it's taken those electrons away. Right, and then you guys have probably already done this, that you can stick a balloon on the wall, and after you rub it on your head and it stays there. Well, why does that happen? It's a phenomenon called polarization. So when when the positive and the negative sides of an atom line up in the same direction, those objects become what we call polarized. So when you have a charged balloon placed against the wall, the negative charges in the balloon are going to push towards the positive charges in the wall, and that's also going to repel those negative charges in the wall. And tomorrow in the lab, you're going to see a really good example of polarization when you do the sweater balloon experiment. Um, yeah, and polarized just meaning opposite. So we have one positive side, one negative side. So in our example here, the balloon is negative, excuse me, and the wall is positive. All right, so your exit ticket today is going to ask you to give us an example of something that allows for electrons to move freely and something that doesn't, and then to explain how an object can become charged. So we can have a positive or a negative charge on something. Okay, so tell me how that works, and then give an example. So what's happening with the electrons? All right, hope you enjoyed this. See you guys.